Okay, so we're gonna move into your day 4 notes, which is more with the sigma notation that we introduced yesterday. Let me fix this. And you're gonna build these formulas at the end as well. So that notation right there, when you see the capital E, that is referred to as sigma. And that is a Greek symbol that is used to indicate the sum of related terms. You're going to take them, you're going to add them up on all sides. So your example looks something like that, or your number can kind of get placed right on the top. So you're going to begin by evaluating these. So what you're going to do is start at the bottom and end at the top. So if I have A equals 1, it means I sub in 1, 2, 3, and stop at 4. So this is my start. This is my stop. And then what you do with all of these is add them together. So to begin here, I'm going to start and plug in where I see the A. So this becomes x minus 1 squared plus, do it again, x minus 2 squared plus x minus 3 squared plus x minus 4 squared. Okay, and that's where you stop. And now you're going to evaluate this. So I would get x minus 1, 1 squared is 1, and then x minus 4, and then x minus 9, and then x minus 16. And that's it. You just combine all of those together and you get a final answer of 4 x's. And all your constants combined together give you 50. Okay, so that's how you're going to leave your answer. Some of these will be numeric answers. Some of these are going to be algebraic and unitary instead. So the next question with the sigma notation. What you're going to notice is different is there's a 4 in the front of it. So when we finally get our sum, you just have to remember to add 4 to our answer. So it's not really done any different. So I'm going to start at 2, end at 5. So I do 3, and I sub in for k. So this is 2 minus x plus 3, and this is now going to be 3 minus x. I got to keep going until I hit my stopping point at 5. So 3, and then this is going to be 4 minus x. And last is 3 and 5 minus x. And at the very end of this, again, we have to remember to add on that 4. So we'll do that in a second. I'm going to take all of these and distribute. So we get 6 minus 3x plus 9 minus 3x plus 12 minus 3x plus 15 minus 3x. And I'm going to do this at this point. You're good. Plus 4. Okay, so now you're going to grab your calculator and you're going to add all of this together. So your x's, I have 3, 3, 3, 3. So that's a total of negative 12 x's. That's nice. You can omit choices 1 and 2. That helps. And now you're going to do 6 plus 9 plus 12 plus 15 plus 4. It gets me a resulting answer of 46. So that matches up with choice 4. Okay, so just a bunch of algebraic work there to do with that distributive property in the middle. So similar here to number 2 is number 3. This one's going to be algebraic as well. So I am going to start this one at 0 instead and sub in the 1 and the 2. So I would go 3 minus 2a to the 0 power plus 3 minus 2a to the first power and 3 minus 2a to the second power. So the left-hand expression, anything to the 0 power. You guys remember that? Anything to the 0 is, I heard it, 1. Yep. And then my next one just becomes plus 3 minus 2a. And then now you have to do a little bit of work. That binomial gets squared. So that means I need to write out 2 identical copies, and I need to FOIL this out. Or if you're someone that favored box method, you can certainly do that as well. I like to just FOIL these out because it's much quicker. So I would do 3 times 3 is 9. Minus 6x is minus 12x, 12a, excuse me, plus 4a squared last. So I'm going to combine that together. This is 4 and minus 2a. So continuing, I'm going to put this back in the standard form. So I want a 4a squared and minus a 14a and plus 13 corresponds with choice 4. Just like that. So here's another that's going to involve a little bit of algebraic work here in the middle. So I need to start this one at 1, and I'm going to plug in 1, 2, 3, and stop after 4. So you're going to replace all of the n's because it says n equals 1, so that goes right there. So we're going to go a minus 1 squared plus a minus 2 squared plus a minus 3 squared, and lastly, a minus 4 squared. This is where it's really helpful to be good at FOILing because I don't think any of you want to do 4 box methods for this. It takes forever. So I go a minus 1, and then we'll quickly FOIL these all out. Then I go a minus 2, followed by a minus 3, and lastly, a minus 4, Okay, so ready? We're gonna go a times a is a squared. Minus 1a is minus 2a plus 1. Next, a times a is a squared. Minus 2a is minus 4a. And negative 2 times negative 2 is 4. A times a is a squared. Minus 3a is minus 6a plus 9. Lastly, a times a is a squared. Minus 4a is minus 8a. Ending with 16. Okay, can you eliminate any answers from this? How many a squares do we have? 4? 1, 2, 3, 4. Yep. That's out. That's out. Now, really, all you have to do is this is multiple choice to figure out do your a's get left over or do they all get eliminated. So I have negative 8a, negative 6a, negative 4a, negative 2a. So that's got to be choice 4. Okay, so you have the 20 a's in the middle. How do you feel with those algebraic? Are they okay? It's just a little bit time consuming, but your procedure is the same and you add everything together when you're done. All right, so next, now you are going to write these. We're going to go backwards. These are going to make use of all the formulas you've been using this week. So the first thing you want to do is looking at your formula sheet, taking out those, of course. And we want to determine whether this is arithmetic or geometric. So I know a sub 1 is equal to 5. What do you guys think? Arithmetic, geometric? What's my common difference here? 2. Yep. The common difference is 2. Meaning this is an arithmetic sequence. So on your formula sheet, grab this one. A sub 1 plus n minus 1 times b. What's going to change this time that you haven't done yet this week is you're going to leave the n in there, and you're going to just write this as a general formula. So I leave the n, and I replace a sub 1 with 5. I leave the n minus 1, and I put the d in as the 2. So instead, I'm going to distribute this. So I get a sub n is equal to 5 plus 2n minus 2. And then in my like terms, if this is going to produce instead a formula for you. So this is 2n plus 3. And what you're going to do is that is going to get placed right here. And then all you have to figure out on the bottom is how to put the first term and how to use the last term. So my first term is 5. Typically, these always start at 1. So if I do n equals 1, do I get that first term of 5? 2 times 1 plus 3? Yep, so that's good. And then last, if I go and check these, it looks like my last term is probably going to be the 20. So let's just check it. Is 2 times 20 plus 3 equal to the last term? 43. So you're good to go. So choice 2. So again, that top number needs to produce your last term of your sequence. Okay. So let's try another one of those. Again, use multiple choices to kind of help you out as well. So you want to express the sum of 1, 3, 5, 7, 9 using sigma notation. Your first step is to write a formula just like the formula sheet. So this sequence is arithmetic as well. So a sub 1 is equal to 1. Common difference is equal to 2. And I'm going to substitute into a sub n is equal to a sub 1 plus n minus 1 times d. And again, the d is just going to get distributed for these. So I have a sub n equal to 1 plus n minus 1 times 2. And then I'm going to distribute that. So my formula should say 1 plus 2n minus 2, which consolidates down to 2n minus 1. Okay. Now, you're going to see from your multiple choices that choice 1 and 4 have the same formula in them. What is different, though, is the top number. So you need to figure out which one will correctly give you the 39. So if I plug in 20, will that work? So 2 times 20 is 40, minus 1 is 39. So you're going to pick choice 1. Because this one's going to be way too large. So you always want to make sure you check that the first term works and the last term. They try to kind of trick you with that. Your next type, no multiple choice this time. So on day 1, a jogger is going to run a third of a mile, followed by 2/3 of a mile, and then followed by 1 1/3. I think it's hard to see the pattern with it written as a mixed fraction, so I'm going to convert this. So if you remember from the past, you do 3 times 1 plus 1 is 4/3 instead. Same thing on this one. 3 times 2 is 6 plus 2 is 8/3. Now what you're able to see is this sequence, instead of arithmetic, this one's going to be geometric, in which your common ratio is 2. So we know a sub 1 is equal to 1/3, and you're going to find your formula right off your formula sheet that says geometric sequence. So now we're going to use a sub n is equal to a sub 1 times r raised up to the n minus 1 power. And all I do is replace these. So I leave the n's there for this type of question. So I'm going to go 1/3 and then times the 2 raised to the n minus 1. So it tells you to write this as an expression that represents the total distance that the jogger ran. Total distance implies a sum, which means we need the sigma. So I'm going to do my formula inside. I just like to use the parenthesis to keep the fraction together. And then you're going to think about how long this runner continued for. So she started on day 1, so n equals 1. And how many days did she continue for altogether? 4 days plus 3 more would be a total of 7. Just like that. So that would be your answer. So that is written in, again, what we call sigma notation, which represents the total distance that she ran. But again, if you're good with the sequences so far, that shouldn't be too much of a stretch to continue. Okay, your last couple. Number 8 multiple choice again. And it says to express this using sigma notation, and you got the multiple choices to kind of help you. Now, I don't know if you remember this from the past or not. It's okay if you don't. When you write a square root is the same thing as raising the number to the 1/2 power. So the square root of 2 is equivalent to 2 to the 1/2. In addition, this here, the cube root of 3, is equivalent to 3 raised to the 1/3 power. So if you remember that, you could actually get this answer really easy. You just look right down here and it's raised to the 1/n. Now, if you didn't remember that, you can still get this because all you have to do is sub in and figure out if it produces your sequence. So I would sub in 1. I would say 1 raised to the 1/1 is equal to 1, so that one worked. The next one I would sub in is 2. 2 raised to the 1/2. And you could type it in the calculator, and that is equivalent to the square root of 2 as a decimal. And then you could do 3 raised to the 1/3 in your calculator, and that is equivalent to the cube root of 3. Okay, so your alternative is to use your calculator and check those decimals. So that would work. All right, so number 9, back to something without the multiple choice, so a little bit tougher. Express the sum using sigma notation. First step, what type of sequence is it? This is another arithmetic. So I'm going to say a sub 1 is equal to 7, as well as my common difference is equal to 7, which means from my formula sheet, I'm going to make use of this formula. And when you're going to write the sigma notation, you are going to leave the ends there. So my formula becomes 7 plus n minus 1 times 7. You're going to distribute that, and your general formula becomes 7 plus 7n minus 7. And if you look at the front and the back, your 7s will cancel. So general formula is 7 times n. So you're going to express your sum using sigma notation. So 7n. And then you are left to determine where it starts and stops. So how do we get this first number right here? 7 times what? 1. And again, most of the time it's usually 1 anyways. And then you're going to use your calculator and ask yourself, 105 divided by 7 means how many terms do we need for this? 15. Yep, thank you. So 15 would be the place that you end. That's all you got to do to get that last one. Feeling good on those so far? Again, you've been doing a great job with sequences, so I don't anticipate any trouble here either. So here's your last. This one you're just going to evaluate the value. So it says b equals 0 is where you start, all the way up to 3, and you're going to replace that where you see this b. So the first one is going to become 2 minus 0i plus 2 minus 1i, or just I, plus 2 minus 2i, and last 2 minus 3i, where I is an imaginary number. So now all you do is add the real together and the imaginary. 2 is 8. 0, obviously, I don't need to include. And then I have -3, -2, and -1, resulting in -6. So your answer for something imaginary does still have to follow A plus BI form. So real followed by imaginary. How do we feel with statement notation? Are those okay? All right, so you have lots of time again today. You have your Delta Math assignments tomorrow when you come in. If you need anything reset, please don't hesitate to ask. You've got problem set 4 to do. And then you have a quiz on sequence Monday when you return. So make good use of your time, please. Again, you have problem set 4 to complete. And you know what, on problem set 4, you may omit number 2 and 3. So you may omit number 2 and 3. Number 1, just to save you a little bit of time, because that one does go to the 20th power. This one's gonna have a pattern to it. So as soon as you notice the pattern, I don't want to give it away, but you'll see what the answer is to that one, okay? So homework you got front and back, you got Delta Math to do as well. And let me know where you have questions.